full demo of Mapalomalia. So we'll start creating a new model. The name of the model will be called Model Full Demo. For this model we will use data from the US Geological Service and also an elevation model from ASGER datasets. We first have to pick the files and upload them. We uploaded shape files in zip form and also GeoTIFF with the digital elevation model that we will use. These are the two supported formats for Mapalomalia. We will enter an APSG code. You can find it in apsg.org and a bounding box in that APSG code in that reference. We will select the geological unit from the file that will denote the field that will denote our geological unit, and then we will import several properties that we can find in the file, and we can take advantage of it. So let's start by editing the base map geology. We can see the geology editor, and here you can browse around the geology. You can move around. You can use the arrows to move around, and the plus and minus signs to zoom in or zoom out. After we select the polygon operations, nodes appear, and we have basically two operations: divide and join. When we divide, we create an arc that connects two nodes. We select the points where we want the arc, and that creates two polygons from one. And when we join, and after that we can set the polygon in any geological unit. Join is the opposite operation. It allows us to pick two polygons that have shared edges and to join them. Okay, so the most interesting part here is that we can create a document using Markdown. Markdown is one of the most used languages for creating content on the internet. In many places you can find full references of Markdown. You can search for them on Google. We have a Markdown chipset in GitHub that you can that was created by someone to edit documents in GitHub, but it's currently pretty well known, the syntax of Markdown. You can create full documents with headings, with tables, with pretty much everything else. But Mapalomalia also has tags for including the objects of the geological model. So you can explain your geological model, what you did, what people is visualizing in a friendly format, and you can also include any object you need to show to your customers, to your bosses, or to your team what you are doing. You can see the full document in a full page, and you can interact with it. It's not an image unmovable. It's a live image. It will be refreshed when you refresh it. Your customers or your bosses will have live information in real time of what's happening with your geological study, with all the objects that you are creating and that you think are interesting to your customer, to your user. So to create a 3D geological model, we have to create a few cross sections. The first cross section is the one that will direct the interpolation, so we have to pick which direction we use. In this case, we pick the direction that is parallel to the x-axis, and we pick the depth below the sea level for this. After we submit, we will have a cross section in no time. Okay, there it is. You can see that the document updated automatically. You don't have to update to refresh the document to see the changes in the objects of the model. Okay, we can see that the base map around the line that we drew of the cross section is shown there. You can see that we can to start dividing, we have to create a few nodes around the edges of the base map so that we can use them to divide the huge polygon that has that is fully a unit not recognized, like we haven't filled yet the space. Okay, so we put a few nodes in the edges, and then we can use polygon operations to see them. Okay, so let's start. By creating an edge from one node to the place where we define the other node. We can see that we can move around while we are creating this edge, and the important part of knowing how to divide a polygon is that you will have to return to the original loop. So you pick one node, you start drawing the edge, and then you pick another node in the same loop. Then you will create exactly two polygons from that loop. Those two polygons will have the same properties in the same geological unit as the previous one, and you will be able to edit the geological unit and the properties for that polygon, for those new polygons that you created. Okay. The other operation is the join. In the join, you pick the polygons and they will be joined into one. But in this case, the geological unit and the properties are picked from the first polygon you pick. Okay. So after doing that, we see that the document has an updated cross section with what we drew. We are not going to be very geological here, and actually this what we draw there might seem is absolutely not geological at all. I'm just drawing shapes, but you see that you can draw any feature with your geological knowledge as you wish. Okay, so let's follow by drawing the second cross section. This time the cross section creator helps me to have a parallel cross section to the one that we already created. If you move it in other directions, it won't let you move there. It will help you keep it parallel. You can also interpolate it. When we interpolate from only one cross section, what we will obtain is like a kind of a picture of what we are building. So the resultant cross section this time will be just a picture with a different topographic profile, but anyway, it will be a kind of a picture of the previous geology that we created. After we wait for a few seconds that the interpolation works, we can start editing the interpolation. So we see here that this interpolation is fully editable. Also, we see that it's very different from what we need to do in that place. Okay, so let's start by dividing the other polygon. Okay, we divided it into 3, and we will select the geological units for each one of the 3 polygons. We made a mistake there. It was not that geological unit. Okay, we will join 2. Okay, so what we're going to do is that we will forget about actual geology for a bit, and we will create a shape that it does not have to do anything with what the geology would look like. So we will create a big shape here, and that big shape will be close to the shape below. So what Mapalomalia does is that it tries to generate a smooth ride between 2 geological cross sections. Okay, so even if we have something disparate like what we just did, which is quite different, and if you see both cross sections, you'll see that most algorithms will have a really hard time guessing what to do with these 2 cross sections. However, Mapalomalia helps you to create an interpolated cross section in the middle that is not geologically correct, because there is no interpolation algorithm that from limited information can guess any geology, but it's a really good start point for you. It's a really good start point for you as a geologist to do what you need to do, and to use your knowledge and to use other information that you might get from the field to really draw what is being seen in the geological model. So there we are creating a cross section just in the middle of the two that we just created. The two cross sections are too far apart for them for any interpolation to work. There is absolutely no way an interpolation knows exactly or knows well what to do, but it doesn't matter because Mapalomalia will try to guess something and to do it as acceptable as it's possible. So there it is. We have the shape above tried to become to connect with the shape below, and that the other shape was more smoothly reduced. However, we see from the surface that there is a huge difference between what we see in the surface and what we see in the interpolated cross section. We can go again to the document, and what we will see here is how from one shape it slowly develops into the other shape. So what the process that we do to create the geological model in 3 dimensions that is really good and that we like it is that we can repeat the method above of creating two cross sections and creating an interpolated cross section. See if it fits with the knowledge that we have of the given region, and if it does, then we do know that the cross sections that are being created between the two are correct. If it doesn't, then we can fix it really quickly, and quickly we will have a geological model which is very powerful and which can give us a good information. So we will not do that right now. We will go to create a block model from the cross-section geological model that we just created, and there it is. We have again the base map. The only thing that you have to do to create a block visualization is to just draw a polygon that will denote where the polygon will draw the 3D visualizations. You draw which is the bottom plane, which is the top plane, knowing that that there are no mountains over 3,000 meters. We will probably get the result that we want, and there it is. There is a block model of what we were doing. It doesn't fit with the surface yet, but it does give us a sense of what we are actually building and what we are actually modeling, and we can explain better because it does feel more solid than just showing the cross sections. So there it is. We can go to the parent study and we go to the article again, We can then include just the objects that we just created. We can include them using another tag. This time the tag is called Visual 3D, and just the name of the model we just created. I'm going to recheck it. Okay, so save, and there we have it. You can actually view the 3D models in its full extent, and the 2D models too, and you can interact with them, you can browse them, you can move around, you can exaggerate the topography if you feel that it's important for you. You can do absolutely anything regarding your geological model. So this document can be delivered to someone that does not want to see the bottom line of what we're building, but just wants the results. And this is way more powerful than just creating a normal geologic that just delivering a Word file. Okay, so right now we pass to permissions. We'll add a contributor, Avija. So Avija is someone that can help us to create our model. Can also create cross sections. Can do everything you can do except assigning permissions. And we will also set the anonymous user to reviewer. So that means that he can view everything but cannot change anything. There it is. When we set the anonymous user to reviewer, we can actually go to the page, log out, and we can see and interact with your model. But you'll probably not want to do that. You will probably just want the spectators to be users that logged in users that would like to review it privately and don't like to see your and you would not like to anyone to see your geological model. So there it is. You can share this link in the whole internet and everyone you want will be able to see it. Okay. Okay, we'll try to enter again to Mapalomalia. And there it is. Getting into the model full demo. Then we'll see that there is another thing we could do with the geological model. We can embed it like a YouTube video. We can paste it on our own website, and that's enough. We can paste this code in our own website, and that's enough to have an article. So if we want to show to some customer or to some user of our data all the relevant information about our project, and we can, if we want to put it on the intranet, and we have a Mapalomalia set up in the intranet, we can put it for everyone that wants to know. Thank you.